Hello, everybody. Okay, we're going to take a look at some challenging algebra today. We're going to solve some non-linear simultaneous equations algebraically. Okay, let's get straight into it then. So we are going to find the coordinates of intersection for some graphs, okay? But this is code. This is code for solve these simultaneous equations, right? Because if I had this graph, I don't know what it is, but I know it looks like a quadratic of y equals x squared plus 2x minus 1, and I have a straight line equation for y equals x plus 5, I'm trying to find the coordinate points there, look. But that is going to be when this expression is equal to this expression, right? When the y values are the same. So that means we can kind of jump to x squared plus 2x minus 1 is equal to x plus 5. And we can start to solve this algebraically without really thinking about those graphs anymore. So how do we solve this? Well, we're going to turn it into a quadratic. So we're going to, first of all, move everything to one side. So I'll take x from both sides. I'll have x squared plus an x, and I'm going to take away 5 from both sides. So I'm going to have the quadratic x squared plus x minus 6 is equal to 0. Now we just got to solve that quadratic. I think I'm going to do this by factorizing because I have 1 as the leading coefficient. And it should be straightforward. I'm looking for two numbers that multiply to make -6 and add to make +1. This is going to be a +3 and a -2. So it's going to give me x values of -3 and +2. Now, to find out what the corresponding y values are, I'm going to plug them into one of these. I think I'll choose the easy one, right? Y equals x plus 5. Okay, so if x is -3, well, that is going to mean that y is 2. If x was originally 2, that means that y is going to be 7. And just to be really clear about this, okay, it means the two solutions are going to be -3, 2, because these two numbers went together. My other solution is going to be 2, 7. That comes from here. Okay, everyone understand how that works? Now, let's go on and try a slightly more challenging example. This time, I'm going to skip straight to the algebraic stuff, right? We're not even going to think about the graph, even though we're finding coordinate points. So they're going to intersect when 2 over x is equal to x minus 1. So we're solving that equation. So to do this, we're going to use our algebraic methods again. I'm going to multiply both sides by x to start with. That's going to give me a 2 on the left-hand side, an x squared and a minus x on the right. Now I'm going to bring everything over to one side. I'll take 2 away. That's going to give me x squared minus x minus 2. We are going to solve this again, nice and simply with a bit of factorizing. So we're looking at two numbers that multiply to make -2 and add to make -1. That is going to be -2 and +1 this time. This is going to give me two values of x that work, x equals to 2 or x equals -1. Now, going back to one of those original equations, that linear one there, let's pop those numbers in to see what the corresponding y values are. So if x is 2, y is going to have to be 1. If x was -1, y would have to be -2. So my two coordinate points of intersection are 2, 1 and -1, -2. Okay, now those ones relatively straightforward. So let's do something upsetting. Let's try something really challenging here. And we're going to look at some different techniques we can use to help us solve the most complex problems. Now, in principle, the same situation is as was before. We have a quadratic, or a very challenging expression anyway, the lower question, and we have some sort of linear equation as well. Now, unfortunately, we can't visualize this very well. I'm not entirely sure what 2x squared plus xy plus 1 equal to 0 is going to sort of look like graphically. But we have an idea, because I'm going to think about this linear one first. Well, if x plus y is equal to 2, well, I'm going to try to rearrange this so that I have it, I isolate a variable. I'm going to choose y, but I could have chosen x. Y must be equal to 2 minus x. I've just taken away an x from both sides. Okay, so now that I've done that, what I'm going to do is every time I see a y in the equation below, I know it's equivalent to 2 minus x. I'm going to swap it for a 2 minus x. So let's write that out. Okay, remembering we've just found that y is equal to 2 minus x. So 2x squared plus x, and look, here's the swap, 2 minus x plus 1 equals to 0. You see, what I've done there is I've eliminated a variable. I've got one equation now with one variable, which means I've got a chance of solving it. So let's simplify it, create that quadratic, and see if we can solve it. So expanding that bracket, we're going to have 2x squared. We're going to have a 2x and a minus x squared and a plus 1 equal to 0. Now we can collect up some terms. We're going to have just 1x squared plus 2x plus 1 is equal to 0. Now, can we solve that by factorizing? Well, yes, we can, because we have the 1 in front of the x squared, which makes it a little easier. We are, again, just looking for two numbers that multiply to make 1 and add to make 2. Of course, we're going to have a positive 1 and a positive 1, which means there's just one solution to this equation. That happens when x is minus 1. And of course, we need to go back and find y. Well, we already found that y was 2 minus x. So y is going to be 2 minus 1. Well, y is going to be 3. So if we were looking for the coordinate point where these two lines met, that would be minus 1, 3. If we're just asked to solve the simultaneous equation, well, my solution would be x equal to minus 1, y equal to positive 3. Okay, now, of course, you may need to use the quadratic formula. You could factorize it in a more complex way using an algorithm in more challenging examples. But the point of this video is just to give you some ideas and techniques of how to solve this sort of simultaneous equation. You'll need to look back at previous videos for different ways to solve quadratics if that's still a challenge.